everyone, welcome to Ganit Academy. In this video, let us study about the addition of integers. So in your previous classes, you have studied about the whole numbers and the addition of whole numbers, right? Similarly, here we will be discussing about the addition of integers. So first, you know about the whole numbers like 0 till infinity, that is all the positive numbers from 0 and then the positive numbers 1, 2, 3, 4, so on till infinity. Those were coming under the whole numbers. And you know 5 plus 3 that gives you 8 and 6 plus 3 that gives you 9. So whenever you added two whole numbers, you were obviously getting a whole number. So we said that, okay, the addition was closed, okay, or we can say the integers were closed under addition. Sorry, whole numbers were closed under addition. Whole numbers are closed under addition. Similarly, we can consider two integers like you have 5 plus 5, and if you are adding it with plus 3, you are getting plus 8. So this is also an integer. See, 5 is an integer, 3 is an integer, 8 is also an integer. And if I consider plus 5 and then I will consider a negative integer minus 3, that is giving you plus 2. So plus 2, this is also an integer. Next, let us consider minus 5 plus 3. This gives you minus 2. And you know that minus 2 also is an integer. This is also an integer. Next, minus 5 plus minus 3. This gives you minus 8. Okay, this is also an integer. But how I am performing all these things? So that is, you have to consider 5, then plus 3. These two are having same signs. Okay, these two are having same signs. So if they are having same sign, you have to find the sum of absolute values. I have already discussed about the absolute value in one of my videos. Okay, so this has absolute value 5. This has absolute value 3. So if I take the sum of these two, that gives you 8. Then you have to place the sign which is common to both the integers. So plus is common to both the integers. So this is plus 8. Similarly, if I take two negative integers, okay, two negative integers, this is when integers are of same sign. Same sign. So these two had positive signs. Now these two have negative signs. So here what I will do, once again I will take the absolute value. This is 3, 5 and this is 3. Now I will take the sum of these two. That is 5 plus 3, it gives you 8. Now I have to place the sign which is common to the integers. That is, minus is common to both. So I will take minus 8. So this is the result. See, minus 5 plus minus 3, that is minus 8. Plus 5 plus 3, that is plus 8. So this is one case. So in the second case, we will discuss when two integers are having different signs. Different signs. That means one integer has a positive sign and another integer have a negative sign. That means a positive integer and a negative integer. So this is, see here, plus 5 plus minus 3. So what I will do, in this case when they are having different sign, you have to take the difference first. So difference of the absolute values. So the absolute value of this is 5. Absolute value of minus 3 is 3. So the difference of these two is 2, right? 5 minus 3 is 2. Now we have to decide the sign. So what will be the sign of this? So the larger absolute values sign will be carried to the result. So larger absolute value is which one? This. That is 5. So what is the sign associated with it? This is plus. So this is plus 2. Similarly, now if I take minus 5 plus 3. Okay. So in this case also, it has different signs. It has a negative sign, it has a positive sign. So take the absolute values. This is 5, this is 3. So what is the difference of these two? It is 2. So now we have to decide the sign. So greater absolute value is 5. So what is the sign associated with it? That is a negative sign. So you have to place it here in the result. This gives you -2. So now see the result in this. Okay, so this is how you will be carrying out the addition of integers. So first case is when both have same sign, and the second case is when both are having different signs. Okay, so if I want to consider this addition on the number line, so in that case what we are going to do? So first I will draw a number line. 0, 1, 2, 3, 4 and here 5. This is -1, -2, -3, -4 and this is -5. So first case I will consider 3 plus 2. 3 plus 2 when I am adding a positive integer to a number. So this is a positive integer. I am adding a positive integer to 3. So in this case, first always take this addend, that is 3, and mark here 3, right? Or you can add like this 1, 2, 3. So this is 3. Now you have to add 2 to it. That means a positive integer. On the number line, you have to move towards right when you are adding a positive integer. So that means 1 unit, 2 unit. So 1 and 2. So now mark this. This is 5. So answer is 5. So if I take 1 plus 2, what will be the answer? You know how to calculate it, but I am showing it on the number line. So first mark 1. Next positive integer. So move towards right. I'll move here. I'll move here. So 1 and 2. So this is the answer. So this is the answer. 3. In the second case, when I'm adding a negative integer. Adding a negative integer. This was when adding a positive integer. Adding a positive integer, move to the right. When you add a negative integer, move to the left. So now, if I consider 3 plus -2, so what will be the answer? So this is the number line, okay, or else I will show it here itself. So first mark 3. I've already marked 3. Now -2, that means 2 units you have to move to the left. 1, 2. So this is the answer. 3 minus 2, that is equal to 1. Or else what you can do, you have to multiply these two. And we have not studied about the multiplication of integers. So let us stick to this method. Okay, so that is moving towards the left. If I consider 2 plus -3. So first you have to mark 2. This is 2. Now I have to move 3 units to the left. 1, 2, 3. So this gives you -1. So what was our normal method? I told you these are having two different signs. Take the absolute value. Take the difference of this and place the sign of the largest absolute value. So that is -1. So from the number line and from the standard method, we are arriving at the same result. Okay. So this is how to perform the addition on the number line. Okay. So next what we can say, commutative property. Commutative property. And before this, for the closure property, you can write for closure property. For closure property, if A is an integer, if A and B are integers, then A plus B is also an integer. It is also an integer. That means whenever you are adding two integers, the result is also an integer. Next comes commutative property. What does this say? You know about the commutative property of whole numbers, right? So similarly, we have the commutative property for integers also. So it is satisfied for the addition of integers. So we can say addition is commutative. Addition is commutative for integers. Same as whole numbers. Okay. So if I consider A plus B, that is equal to B plus A. So if A and B are integers in general, then A plus B is equal to B plus A. This is the commutative property. So let us prove this. 3 plus 2 is equal to 2 plus 3. This is my left hand side. This is my right hand side. So this is my LHS. This is my RHS. So 3 plus 2, you know they are having same signs. So take the sum 5. Place the sign which is common to integers. This is also having same sign. Take the sum and place the sign which is common to integers. So 5 is equal to 5. So you can keep this 3 this side, or you can keep the 3 this side. Whatever you are going to, if you are altering the positions also, it does not matter. It will be giving you the same result. So it is commutative. Suppose I will take 3 plus minus 2. So one is a positive integer, another is a negative integer. So in this case, I have to take the difference of the absolute values. That is 1. Next, I have to place the sign which is of the larger absolute value. So that is plus 1. So if I interchange the position minus 2 plus 3, this also will be giving you the same result. You can check it using the number line also. See 3, this is 3 plus minus 2. That means I am adding a negative integer. That means I have to move to the left. So 1 and 2 units. That gives you 1, right? So if I take minus 2, so that means I am going here. Then from this I am adding a positive integer. 1, 2 and 3. Again I arrived at 1. Okay. So this is proving the commutative property. So we can say addition is commutative for integers. Next, let us take the associative property. Let us take associative property. You know that the addition was associated for whole numbers. Similarly, we can consider for the integers, and let us prove that the addition is associative for integers too. So here I will consider A plus B plus C. So A, B and C are integers in general. Okay, A plus B plus C, that is equal to A plus B plus C. This is associative property. So what is that? First I will solve these two and then I will add with A. So now we have to verify that it is equal to this one. Here first I will add these two, then I will add with the C. So let us take A as 10, B is 5, C is 2. So 10 plus 5 plus 2, 10 plus 5 plus 2. This is my LHS, this is my RHS. So here I have to consider this, here I have to consider this. So you know 5 plus 2 is 7. 10 plus 7 is 17. Here 10 plus 5 is 15. 15 plus 2 is 17. So we can say that LHS is equal to RHS. Okay, LHS is equal to RHS. So we have proved this. That is when all the integers are positive integers. So next I will consider A is equal to 10, B is equal to minus 5, C is equal to 2. So 10 plus minus 5 plus 2. 10 plus minus 5 plus 2. So let us see the LHS first. Minus 5 plus 2. We have already studied the addition of integers having different signs. So take the difference 5 and 2 3. Place the sign which is of the larger absolute value minus 3. So 10 plus minus 3. Now again we are adding the integers of different signs to take the difference, that is 7, and here it is plus, so this is also plus 7. Here again we are adding, in the RHS we are adding the integers of different signs. So 10 and 5 has the difference 5. Larger absolute value is 10, that is positive 1, plus 5 plus 2, that gives you 7. So this is 7, this is also 7. So here also we have proved that a plus in bracket b plus c, that is equal to in bracket a plus b plus c. So now let us take all negative integers, that is minus 10, minus 5, minus 2. So in this case, first let us solve the LHS. Minus 5 plus minus 2. Okay, here it is minus 10 plus minus 5 plus minus 2. So this is my LHS. So first let us solve that. First I will solve the bracket 1. Minus 5 plus minus 2. This is the case 1 where integers are having the same signs. So take the sum, place the sign which is common to integers. So this is minus 10. Okay. Now again same sign. 10 plus 7 is 17, minus 17. Here also these are having same signs. 15 minus 15 plus minus 2. Again same signs. So 15 plus 2 is 17. Place the sign common to integers. So minus 17 is equal to minus 17. So we can say that the addition is associative for integers. Okay, addition is associative for integers. Next, let us take additive identity. You have already studied about the whole numbers, and there you had seen that 0 is the additive identity of the whole numbers. Similarly, 0 is additive identity for integers also. You know that whenever a number or whenever a 0 is added to a number, it gives you the same number. Okay, for whole numbers it was whenever you add the 0 to any whole number, it gives the same whole number. For example, 0 plus 10, it gives you 10. Similarly, for integer, in general, if I consider a as an integer, if you add 0 to any integer, it gives the same integer. Or if you add like this, that is also giving you a. So 0 plus a is equal to a plus 0. This is from commutative, that is equal to a. Okay. So minus 10 plus 0, that gives you the same number, minus 10. 10 plus 0 equal to 10. Similarly, 0 plus minus 5, that is equal to minus 5. 0 plus 2, that is equal to 2. Okay, so 0 is the additive identity of the integers. Okay, so adding 0 means you are adding nothing. Something which is not there, if you are going to add something which is not there, will it make any difference? So for example, I have 2 pens in this hand. I have nothing here. If I add something which is not there, will it make any difference? No, you will be having 2 only. You had 2, you are adding nothing. You don't have any pen here. You are adding nothing. But what will be your answer? That will be 2. That will make no difference. So this is the additive identity. And we have already studied about the additive inverse. That is, if a is a number, additive inverse will be minus a. If minus a is a number, additive inverse will be plus a. So if you are adding a number with its additive inverse, that will give you the 0 as a result. A plus minus a, that will give you 0. So that is about the additive inverse. So this is all about the addition of integers.